will now look into fuzzing techniques that automatically use information from the program at hand in order to guide the input generation process towards specific features. One of these features that we are looking into today that help fuzzers be guided towards specific programming features is coverage. Coverage means that we are tracking which parts of a program are being executed. So if we have a small program, for instance, and we know that some specific parts have not been executed yet, then we typically want to test them, because if a line of code is not executed at all during testing, then this means that any bug that may still be in there may still loom in there, and we want to go and we want, of course, our tests to execute every single line of code, because if they do not execute this code, then there is no chance for the test generator, for the fuzzer, to find any bugs in there either. So achieving a high amount of coverage, covering as many features of the program as possible, is important. And these features typically are lines in the program, but can also be more advanced features such as branches in the program, or function or pairs of functions calling each other. There's a great portfolio of things that can be measured during an execution. Now, if you have ever wondered why all of what we're doing here actually comes in Python, there's a very simple reason for that. So no other language, or pretty no other mainstream language, is as easy to use for finding out which lines have been covered, or more precisely, for dynamic analysis of executions than Python. So the neat thing about Python is, as I said, this is one of the languages in which it is extremely easy to find out what's going on during a program execution. Actually, I have yet to see another language in which this is as easy as that. And it is this ease, the ease of finding out what's happening during execution, which actually made this whole book be written in Python rather than in whatever other language that we have. We could do Java or C or whatsoever. Okay? What Python provides is a mechanism that allows a so-called tracing function to be executed at any point during execution. Let us try this out using a simple example. We're first going to introduce a small function called CGI decode, which is a function which takes a so-called CGI encoded string. Here we go, this is CGI decode. So here we go, CGI decode at the very beginning. And we define it, and let's see whether this actually works. Well, come on. Please be yellow. Yes, this has worked. And CGI decode takes a string as it is used, among others, within URLs. You know, if you search for something within URLs and you want to search for a string with a space, then the space is not valid within the URL. It has to be encoded. And what browsers then typically do, they encode the space with a plus symbol, and we can use the CGI decoding function to actually decode these strings again, turning the plus symbol back into a space. There's a number of such replacements in here. So CGI decode replaces a plus by a blank, and if you have %xx, then this gets replaced by the character with the hexadecimal number xx. So if I put in, well, let me just try that. 30. This is ASCII 48, if I recall it right. That's a 0. Yes, we have it. Or actually also %20, that's ASCII 32, that's a space. Here's another way of encoding a space. And but you can also come up with invalid encoding. So if I put in ZZ, hello ZZ world, then I should get an expression, a value error that we just used an invalid encoding. So, and of course I can now test this function, and when I test this function I want to come up with inputs that cover as much of this code as possible. Here we go. Oops, no, sorry, that was the wrong character. Here we go again. And of course I also want to test the individual features in there. So how do I measure the coverage? Well, one way is simply to go now to take a string and then to go through this code and to find out which parts of the code actually have been covered. And I can certainly do this, but then I have to execute the program manually, which is not fun. It's much easier to actually have a piece of code actually measure this coverage. And again, this is where Python shines. Because Python has a so-called tracing mechanism. This tracing mechanism allows a function to be executed for every single line of the program as it is being executed. So we're going to look into this right away, and I'm going to define such a very function which does that. So let me see, here we go. So this is traditionally called traceit. Traditionally, I'm not sure, that's the name that I typically use. And this function is invoked for every single line that is executed. It gets a couple of parameters which we're going to look into in a moment. And it gets a frame. A frame is the current set of local variables as well as the code that is being executed. These make up a frame in a program execution parlance. It also gets an event. The event is a string, which is either something like line, that means a new line has been executed, or call, a function has just been called, or return, a function just returned. And if I recall it right, there's also an event for exceptions. An exception has just been raised. Yes, you can trace these too. And then there's also an argument, which for specific events such as return gives additional information such as the return value. Okay, and this then returns a function. We're going to come to that in a moment. So this function now gets executed, and that's and we can do something very simple here. So we can just, well, why not simply go and print out the event? Well, that's one thing. You can certainly do that. But you also want to have more information. And the frame actually also allows you to access, this is a struct which also has a couple of attributes which are very interesting. In particular, you can go for frame line number. So current line is the current frame line number. And you can also look for the actual function name, which is a string. Function name, here we go, is frame dot, oh, well, it's actually a bit more complex. You first have to access the code object. This is the code that is being executed, and this code actually does have a name. So now we have the line and the function name. And I see that my editor is complaining here. What is it complaining about? Probably about line not being used. Line is assigned to but never used. Thank you so much. Now we know this. But what we do now is we actually print all of this out. Let's first, well, it doesn't matter really. Line and line. Here we go. Function name, event, line. Oops. Yeah, well, let's make this slightly nicer. So what happens here is the event, and we also have a line in here. So that's a bit neater. So the traceit function actually returns itself, and this is how we can indicate that the tracing function should continue to be invoked. It can also return none, and if it returns none, then the tracing will be automatically turned off. So, great! I'm always happy if I can define something without the syntax error. And now we can actually define another function. Trace CGI decode. Here we go. That's not to or well, let's give it a string. Here we go. Let's make things easy. And we also need to write import. Oops. We also need to write import sys because we need that. And now what we do is we turn on tracing by defining this traceit function. So, and you can also see what's happening in here. Set the global debug tracing function, which will be called on each function call. See the debugger chapter in the library manual. Well, here we go. So this turns on tracing, and from there on, for every call, this traceit function will be invoked, and if it returns itself or some other function, this function will also be called for every line along the way. So sys.setTraceit. Now we can actually go and invoke the whole thing, CGI decode, and this will now be invoked with tracing enabled. And then we turn off tracing again. Do not forget to turn off tracing again when you're in Jupyter Notebook, because otherwise tracing will remain enabled while you're in the Jupyter Notebook, and you're going to get megabytes and megabytes of traces as Jupyter Notebooks compute along. Okay, and this is how we can turn it off again. Oh, what did we forget? We forgot to actually return the return value. Okay, return ret. Here we go, Babs. Oops. Okay, wonderful, wonderful, wonderful. Here we are. Okay, so we turn on tracing, we invoke the function in place, and we turn it off again. Okay, so what can we do with that now? Well, we can invoke it. Trace CGI decode of, well, hello world. What's going to happen when we do that? Well, we're sure going to get plenty of printouts. Let's keep fingers crossed that things work just as they should. We do that. And it worked. Oof, I'm so happy. Because now we can actually get, this is what we actually get. This is the trace. These are the individual lines as they're being executed. So for every line we see CGI decode. This is the code that is being executed. This here is the event. First we have call, and then we have line, and we have line, and we have line again. And then finally here we have the line number. And this line number, if you do this in Jupyter Notebook, is relative to the cell in which this is executed. So this is line number 1, this is line number, this here is line number 2, and this is line number 3, 4, 5, 6, 7, 8, 9, 10, and so on. So this is of course very rudimentary, this tracing function, because, well, we should also be able to actually see the code as it's being executed. So this is just very primitive in here. But there's another nice thing in here which is also fun, because you can even also access the variables as the program is being traced, because there's also an attribute called flocals, which allows you to access the local variables. And we can even, let me see whether we can just add this in here. This could be very interesting. Oh, I think vars is, let me make this vars. I think vars is a reserved name in Python. So let's make this variables. So we can now go and, do we have that? Frame flocals. What do we have? Frame flocals. Okay, here we go. So let me try this again. And now comes something really nice, because now you can also see the individual variables with all their values. So you see when CGI decode is being called, there is a variable called s with a value of hello world, which is not very surprising because this is the parameter in here. After being in line 15, we also have an array named hex values that is now being initialized. And as we keep on going through the program, through the individual lines, we see that there's a variable called I. This is an iterator over the string, which initially is 0, and which then continues to be 1, and then a couple of lines later, it has reached the value of 2, and there's also another variable which is called C, and this variable C always has the value of the current character in position I. So right now we are in the position 2, and this is the E that we're looking at. So there's also a string T, which happens to be the string in which we accumulate the decoded string. If we go further down here, you will see that in the end T is equal to the value of hello world, and this hello world string is exactly what we are returning in the very end. And if you're looking deeper into the code of CGI code, you're going to find out, yes, we have a string at the very beginning, we have these hex values in here that are being assigned, and we do have this string T, to which we add one character after another, and which is also being returned at the very end. This is the base of the tracing capabilities in Python, which makes Python a super powerful language, because all these features, being able to exactly trace which lines are being executed, and better even which values individual variables happen to have, is, well, how long did it take in here to implement this? This was 1, 2, 3, 5 lines of code. In a language like C, for instance, which is compiled, building such capabilities would probably take you some months to build, because you have to adapt them all into the compiler. You have to make sure that this knowledge is being passed over to some debugger, or you have to instrument the code such that all of this stuff is being printed out. To instrument the code, you also need to see which types there are, which requires static typing knowledge. None of this is particularly fun. In Java, doesn't make life easier. I think if you're doing interpreted languages such as the Unix shell language, there you have an easier way to actually find out what's being executed and when. But I'm pretty sure that Python is one of the easiest languages here ever. So now we can make this a bit more. Now, and this tracing function, which in the beginning just tells us which event has taken place, which line and which variables we have, is now something that we can build in a much bigger fashion. And for this, we introduce a class named coverage. And this is a simple class in which you use as follows. You write with coverage as cov, and then you write in the functions that you would like to cover. And then there's methods such as trace and coverage, which allow you to return the list of all lines executed in all functions being seen, as well as the set of all locations that you've seen over time. We can actually look at this at the very end of this notebook, how these things work. So I'm having here the coverage class. So first let me execute things such that it actually also works. So where are we? We are over here. So let me just execute the whole CGI decode thingy here at the very end, which now takes a moment. This is the coverage class, which I can just execute here. And if I execute this in this with clause, anything that is within this with block will automatically be traced. And at the end of this with block, also important, tracing will automatically be turned off. Okay. And now we can actually return the trace from this function, which is again a list of lines being executed, except that this trace now comes as a data structure, comes as a list of locations, and each location consists of a function name and a line within that particular function. And you can also use the coverage method, which returns the same information as a set, meaning that in here we're not having a sequence of lines being executed, but simply the set of lines that ever were executed, which by construction is typically shorter than the list. The list also has repetitions in there, of course. The set only simply flags every line that has ever been executed. In the chapter, you will also see material on how to turn this information again into something that is a bit more readable by using inspection, there's the Python module for that named inspect, to actually access the lines of code of a function and then to print them out, which is very neat. And we also have material in here for those of you who prefer to do such experiments with C. We also do have some material here on how to capture such coverage for C programs. For this, we take the CGI code and we translate it into C source code, which we then happily, well, this is the C source code. I'm not sure, it's a bit more, well, star plus plus S. Yep, sure, that's typical C, there you go. Which we then compile and which we then execute, and where we also show how to extract coverage from these C files and eventually also print these out. And we also show how to actually read this in to obtain coverage sets, and then we can do with this, we can actually then apply the same coverage computations as with Python programs. This, of course, assumes a bit of infrastructure that for C programs already is present. And I encourage you to actually, if you're familiar with C and you have a C compiler available on your machine, you can just go and try this out. And this is already the entire story we have about code coverage, simple mechanisms to obtain runtime information dynamically from program executions, which is really, really great and nowhere as easy as in Python, and I repeat myself here. And this coverage is what we are going to use in the upcoming weeks, in the upcoming chapters, in order to guide fuzzing such that we maximize coverage. And this is something that will keep us busy for the weeks until Christmas. And after that, after that, we will be able to look into our second project, and we will also start going into, and after that, we will go into a couple of applications, namely using all these techniques to systematically fuzz APIs or web servers or command lines and other stuff, which gives you a couple of ideas of how to make use of all these techniques.